Everyone, welcome to today's tutorial. So if you have any questions, feel free to contact me on any of my lines here on the screen, and click the subscription button there so that you don't miss the videos that I'll be posting. Alright, so the question is find the dimensions of mass in terms of force, length and time. So this one is also a question from dimensional analysis. So they're saying we find the dimensions of a mass in terms of force. The force, so say force will raise it to the power x, and then they're saying the length will also raise it to the power y, and then the time will also be raised to the power z. So if this is the case, to find these dimensions, this is a straightforward question. So we are going to express mass in its fundamental dimensions. So how do we do that? So we're going to say m. Okay, so m is going to be equal to m is okay, from the formula for from the second law of motion of Newton. From Newton's second law of motion, we know that force is equal to mass times acceleration. So from there we can make mass the subject. So mass is equal to force over the area. Oh, sorry, force over the acceleration. Sorry, force over the acceleration. So the force over the acceleration there, meaning m can be written as using dimensional analysis. F there is simply just I think this one is a straightforward question. Let me not even go this far, or let me write it and then I'll write it first in dimensional analysis. So I have f there, and then acceleration there. The dimensions for acceleration is simply just you derive them from this expression, or from this view, point of view, which is a is equal to the velocity over the time. Then velocity, the dimensions for velocity, the dimension for velocity is equal to mass over mass per second. The what do we call this? The units for velocity is m over s, and then time is also s. So this one is m over s squared. So m, according to dimensional analysis, is just m. Then s, which is just the time there. So this one is t squared. So meters rather. So meters, according to dimensional analysis, meters, this one is supposed to be length, not m. So this will be length, because meters is the unit for length. So the length over that. So this can be written as length times t to the power -2. So we have L t to the power -2. So when you take everything on top there, we're going to have mass is equal to F L to the power, L to the power -1, and then t to the power 2. So this is what I'm going to put here. So I'm going to have F, then I have L to the power -1, and then I have t to the power 2. So I'm going to equate this and that. So I'm going to have F to the power 1, L to the power -1, t to the power 2 is equal to, so dimensions for F there, I'll just write F to the power x, since they want us to show it like that, to leave it as a force. And then dimensions for length is also a capital letter L to the power 1. Dimensions for time, capital letter T to the power Z. So since F to the power 1 is equal to F to the power x, since the denominators are since the bases are the same, it means that the powers are also the same. So we can say we can say 1 is equal to x, therefore x is equal to 1. Then we take L this side is being raised to the power 1, then on the other side it's being raised to the power y. So we're just going to say y is equal to 1. Then we also take t. So t this side is raised to the power 2, on the other side is raised to the power z. So z is equal to 2. So that's how you deal with that. Hence the mass in terms of force, length and time is simply just mass is equal to F to the power 1, and then we have L, length, which is the length to the power y. Which one is y? Y is 1. Oh, here we had -1. Sorry, this one is supposed to be -1. So this will be L to the power -1, and then the time will be to the power power 2, because time is having z. So this will be to the power 2. Therefore, m is equal to FLT squared. This is the answer they wanted. Alright. Oh, this one, I don't know why I'm forgetting to write -1. Okay, let me just write them properly. Yeah, so this was m is equal to force L to the power, and then this was t. So from there we can now say m is equal to F times t squared. Then this L to the power -1 can be written as over L. So this is the mass they wanted in terms of force, time and length. Alright, thank you very much for watching today's tutorial. So if you have not yet subscribed to the channel, make sure that you click on the subscription button there so that you don't miss out the videos that I'll be posting. My name is Harmtedy. Shalom, shalom.